Hi, in this video I will go over two problems on week 6 assignments for mymathlab, and the first question is question 17 on your week 6 homework assignments. So in this problem we are asking to find the confidence interval for the population mean mu and the margin of error of the mean as well, and then interpret the results. Now, in a random sample of 22 people, the mean commute time to work was 33.5 minutes and the standard deviation was 7.3 minutes. Assuming that the population is normally distributed and use a t-distribution to conduct a 99% confidence interval for the population mean mu. Okay, so we are given the sample size. This is the sample size n, so your n is equal to 22, and your sample mean, this is the mean of this sample, 22 samples, so this is your x bar, the sample mean, and the standard deviation was 7.3, so this is the sample standard deviation. And we know that we need the degree of freedom in order to find the t-distribution. So the degree of freedom is equal to n minus 1, or in this case 22 minus 1 is equal to 21. Okay, so we have everything. Now what is the formula to find the confidence interval for the population mean mu? We know that we have the lower bound and the upper bound for the confidence interval, and the lower bound is found by the formula x bar minus t alpha over 2 multiplied with s over the square root of n, and your upper bound, we need the lower and also the upper bound. The upper bound we just take the same thing here, but then we add them instead of the minus, so it's still t alpha over 2s over the square root of n. Now looking back at the problem, we have everything x bar, we have s, we have this n, so all we have to do now is the value of the t alpha over 2. So how do I find the t alpha over 2? So let me draw the curve. So let's say I have the curve here. This is the curve, the distribution, and at the center is when you have t equals 0. And let's say that you have, this is your t alpha over 2, and on the left side is minus t alpha over 2. Now we are looking for 99% confidence interval. 99% confidence interval is telling you that your alpha is the other remaining percentage, or 1%, 1% or 0.01. And to find the alpha over 2, you just take this, divide by 2, and that is 0.005. Remember, alpha over 2 is the area to the right of t alpha over 2. So this area here is the value 0.005 right here. Now we are looking for t alpha over 2. We are looking for this value right here. And the way we do that is we can find t alpha over 2 by two different ways. You can use the graphing calculator TI-84. You can find t alpha over 2 by using the function inverse t, and the inverse t function, it will take two different arguments. The left input is the area to the left of t alpha over 2, or the blue area right here, and we know that the whole thing has the area of 1, and this area is already 0.005, so the remaining area of the blue one should be 1 minus 0.005. And the left area of T alpha over 2 will go to the first argument here. And then the second input is your degree of freedom, which is 21. And then now we can use the TI-84. Let me show you that here. So what we do now is you go to the distribution, second vars, and then hit the invert T. The area is what you have here, 1 minus 0.005. Degree of freedom 21, and then enter, and then hit the enter again. So that will give me about 2.83. So that is my T alpha over 2, 2.83. Now, if you don't have the graphing calculator, then you can also use the T distribution table. And let's try to open up that. So let's say that we have the T distribution table. Okay. Now we have the degree of freedom 21, so that should be this row right here. And remember the area to this is the T distribution for the area in the right tail. And remember that you have the area of the right tail of T alpha over 2 to be 0.005. So now you are looking for 0.005, which is this column, and down to this row 21, go all the way down 2.831, which is the same value that we got here, 2.81. Okay, so now after you got that, you can just plug in the value here. So your X bar for the lower bound, your X bar 33.5, your T alpha over 2 is 2.83. My standard sample standard deviation is 7.3, and then my N 22. And if you do the calculation here, you should get the value of 29.095. And then we do the same thing here. We add instead of the minus, so 33.5. We add 2.83, 7.3 divided by the square root of 22, and that will give me 37.904. And they only ask you to round to one decimal place, so this is 29.1, this is 37.9, which is right here. Okay. And then now the next question, they ask you for the margin of error. So we are looking for the margin of error. The margin of error, and that is the notation, the big symbol E. And the margin of error is simply just this portion right here, or this value, or the same thing. So 2.83 times 7.3 divided by the square root of 22, and that should give me 4.4. If you round it to one decimal place, that is 4.4. Now the conclusion is that we, with the 99% confidence, it can be said that the population mean, we are looking for the population mean, commute time is between the bounds of the confidence interval between these two minutes, the lower and the upper. And that is the end of this problem. Okay, the next problem is your question 19 on the same assignment, week 6 assignments. And in this question, you are given the table. This is the monthly incomes for 12 randomly selected people, each with a bachelor's degree in economics. Now, the first question is they are asking you to find a sample mean. We can find the sample mean by adding all the numbers together and divide by 12 because we have 12 of them. But we can also use the graphing calculator to do that. It will help you to speed up the process. Now, first thing is you can store all of your data into the list of L1, L2, L3. So to get access to the list, you go to Start, go to Edit, hit Enter, and then you store all the number into the list of L1. So we can do that here: 4450.44, 4455, the second number, and then just keep going on. 25, 96.08, 0.55, 4527.98, 4023.12, 4366.44, two more number, 4407.36, and the last one. So after you store all the 12 data value in here, to find the mean, the sample mean, you go to Start, Calculation, the second one, choose the one variance statistic. So hit Enter for the first option, and then the list is list L1 because we store the data in the list L1. Hit Enter, 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 and then my mean value X bar 4263.0 if you route to one decimal place, and that is the values right here. Now to find the sample standard deviation, is also listed here. Sample standard deviation 260.1, which is right here. So the graphing calculator can help you to find the sample mean and the sample standard deviation right away. Okay, now construct a 90% confidence interval for the population mean. So how do I do that? Again, we follow the same steps as we saw earlier in the last problem. To find a confidence interval, remember we had the formula for the lower bound, X bar minus T alpha over 2 S square root of N, and for the upper bound we have the plus formula S over the square root of N. Now again, I draw the curve. This is T equals 0, this is T alpha over 2, this is minus T alpha over 2. We are looking for 90% confident. 90% confident. That means my alpha is the order 10% or 0.1, and therefore alpha over 2 is 0.05. Now to find my T of alpha over 2, I simply use the remember, okay, go back to the last case. It's similar that this area here is the red portion, 0.05. So we are looking for the T alpha over 2. We use the function inverse T, and then what about the area to the left of this one, which is this blue area? So that equal to 1 minus 0.05, because 1 is everything. So you minus this red portion to get you the blue one. 1 minus 0.05, and then the degree of freedom, in this case we have 12 for the data, so n minus 1 is 11. And if you use the calculator, we can go to second distribution, area 1 minus 0.05, 11, That will give me 1.79, 1.80. Let's just route 1.80. So it's around 1.80. And now you have everything. X bar is right here, 63.0 minus 1.80. S is right here, 260.1 divided by, and it's 12. And then the second K, you add that instead of minus. And if you do that correctly, you should get this value for the lower bound, this value for the upper bound. And that is how you complete these problems. Thanks for watching.